Developing real-world applications. Recognizing cats and dogs is a cool problem but less likely a problem of importance. Real-world applications of image classification used in products may be different. You may have different data targets. In this section, you'll learn the tips and tricks to tackle such different settings. The factors that should be considered when approaching a new problem are as follows. The number of targets. Is it a 10-class problem, a 10,000-class problem? How vast is the inter-class? For example, does the different type of cats have to be identified under one class label? How vast is the interclass variance? For example, do the different cats have to be identified? How big is the data? How balanced is the data? Is there already a model that is trained with a lot of images? What is the requisite for deployment inference time and model size? Is it 50 milliseconds on an iPhone or 10 milliseconds on Google Cloud Platform? How much RAM can be consumed to store the model? Try to answer these questions when approaching an image classification problem. Based on the answers, you can design the training architecture and improve the accuracy as described in the next section. Choosing the right model. There are a lot of options for architectures. Based on the flexibility of deployment, you can choose the model. Remember that convolution is smaller and slower, but dense layers are bigger and faster. There is a trade-off between size, runtime, and accuracy. It is advisable to test out all the architectures before the final decision. Some models may work better than others, based on the application. You can reduce the input size to make the inference. Architectures can be selected based on the metrics as described in the following section. Tackling the underfitting and overfitting scenario. The model may be sometimes too big or too small for the problem. This could be classified as underfitting or overfitting, respectively. Underfitting happens when the model is too small and can be measured when training accuracy is less. Overfitting happens when the model is too big and there is a large gap between training and testing accuracies. Underfitting can be solved by the following methods. Getting more data. Trying out a bigger model. If the data is small, try transfer learning techniques and data augmentation. Overfitting can be solved by the following methods. Regularizing using techniques such as dropout and batch normalization. Always watch out for loss. The loss should be decreasing over it. If the loss is not decreasing, it signals that training has stopped. One solution is to try out a different class imbalance can be dealt with by weighting the loss function. Always use TensorBoard to watch the summaries. It is difficult to estimate how much data. This section is the best lesson on training any deep learning models. Next, we will cover some application-specific guidance. Gender and age detection. Applications may require gender and age detection from a face. The face image can be obtained by face detectors. The cropped images of faces can be supplied as training data, and the similar cropped face should be given for inference. Based on the required inference time, OpenCV or CNN face detectors can be selected. For training, Inception or ResNet can be used. If the required inference time is much less because it is a video, it's better to use 3 convolutions followed by 2 fully connected layers. Note that there is usually a huge class imbalance in age datasets, hence using a different metric like precision and recall will be helpful. Fine-tuning apparel models. Fine-tuning of apparel models is a good choice. Having multiple softmax layers that classify attributes will be useful. The attributes could be a pattern, color, and so on. Brand safety. Training bottleneck layers with support vector machine (SVM) is a good option as the images can be quite different among classes. This is typically used for content moderation to help avoid images that are explicit. You have learned how to approach new problems in image classification.